So the next topic is mass and weight. So we already learned in our lower grades that what is mass and what is weight and stuffs. So now let us discuss what is mass. So mass is nothing but the quantity of matter contained in the body. For example, let us take a sack of sugar. So in that mass will be the amount of sugar crystals present in a body. So that is called as mass. And uh, what is called weight? Everyone will have a question, that is what is called weight. So weight is nothing but it is also mass, but it depends on gravity. Mass does not depend on gravity, so it will be same from place to place. For example, if you measure the sack of sugar crystal in earth, that is 35 kg, in moon also it will be 35 kg only. So mass does not depend on gravity, it will be same throughout the place. So it will be same from place to place. Okay, SI unit of mass will be kilogram. Okay, in case of weight, so weight is nothing but it depends of gravity. So we know that earth attracts every object with a certain amount of force, correct, which completely depends on mass and also the acceleration due to gravity. So weight is also mass which depends on gravity. So there is a formula of weight as W is equal to m into g. As told, it depends on mass and gravity. So as the weight depends on mass and gravity, the mass of the object will be differing from place to place, because when you consider the weight of human being on earth, let us assume as 45 kg, since the value of g is 9.8 meter per second square in the earth, whereas in moon it is 1.7 only. So the weight will be quite less. Okay, so it differs from planet to planet. So weight is not constant. The value of weight will be varying as the radius of the planet varies, as the acceleration due to gravity varies. So this is all about weight. Okay, so yes, okay, and so the next topic will be thrust and pressure. So thrust. So have you wondered, let us ask questions. Have you ever wondered why a camel run easily in a desert? Why an army tank weighing more than 1,000 tons rests upon a continuous chain? Why a truck or a motor bus has much wider tires? Why cutting tools have sharp edges? In order to address these questions and understand the phenomena involved, it helps to introduce the concept of the net force in a particular direction, that is thrust, and the force acting on per unit area, that is pressure. Okay, let us understand the meaning of thrust and pressure by considering the following situations. So first situation I'll give you. You wish to fix a poster on a bulletin board. Okay, to do this task you have to press the drawing pins with your thumb. You apply force on the surface area of the head of the pin. This force is directed perpendicular to the surface area of the board. This force acts on a small area at the tip of the pin. So this is the case number 1. Okay, let me give another situation as well. You stand on a loose sand. Your feet go deep into the sand. Now lie on the sand. You will find that your body will not go deep in the sand. In both cases, the force exerted on the sand is the weight of the body. You have learned that weight is the force acting vertically downwards, the force acting perpendicular to the sand. The force acting on an object perpendicular to the surface is called as thrust. So thrust is nothing but it is a simple force that is acting perpendicular to the surface. So when you stand on a loose sand, the force, that is the weight of the body, is acting on the area equal to the area of the feet. When you lie down, the same force acting on the area equal to the contact area of the whole body, which is larger than the area of the feet. Thus, the effects of forces of same magnitude is different for different situations. In the above cases, thrust is same, but effects are different. Therefore, the effect of thrust depends on area on which it acts. The effect of thrust on sand is larger while standing than while lying. The thrust on unit area is called as pressure. So pressure is given with the formula thrust by area, and the unit of pressure is Pascal or N by meter square or Nm minus 2. So in honor of scientist Blaise Pascal, the unit of pressure was Pascal, and it is denoted by the letter capital P and small a, that is Pa. Okay, so this is all about thrust and pressure.